So this is actually day 2 of these notes. I gave you these notes on Friday, and we should have already graphed the parent graph right here. We graphed it with the XY table. We used consecutive integer inputs. And if we went through it, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Going backwards, negative 1 squared is also 1, negative 2 squared is also 4, negative 3 squared is also 9. And when we graph them, we get these coordinates. Now, so far, I've only graphed the 0, 0, 1, 1, 2, 4, 3, 9. These over here on a graph in blue, and you can see that they do provide a perfect reflection over the axis of symmetry. And that's why the axis of symmetry is so important. The axis of symmetry is that vertical line. I want you guys to draw it dotted, going right through your vertex, wherever that may be. So here's our parabola that you should have already had graphed from Friday. It does continue to go up and to the left forever, and it does continue to go up and to the right forever. What do I mean it goes to the right forever? You could plug in the value 10, and if you go 10 squared, that would give you 100 way up here off the paper. So it does go to the left and right forever. This does have a minimum value at the vertex 0, 0. Okay, so we want to learn faster methods of graphing instead of using this whole XY table. And a quick shortcut that'll make it twice as fast is not to plug in every single coordinate. It's to understand that your axis of symmetry provides a reflection. So if you were to just find your vertex and then maybe 1 or 2 more points, you'd be able to reflect them over to the other side by counting how many spaces away from the axis of symmetry it is. So this is 2 units away, 2 units away, boom, you have your point. 1 unit away, 1 unit away, boom, you have your point. So the axis of symmetry and understanding that there's a perfect reflection on the other side will make it so much quicker to graph. Let's go over here and let's graph these guys. Let's start with this one. So we're going to start again by finding the vertex. The vertex is the most important point of any parabola. It's the highest or the lowest point. Not only that, it shows you where your vertex is at, or where your parabola is at on the XY plane, and there's an axis of symmetry that runs vertically right through it. So there's our vertex. A vertex is a coordinate, an x value and a y value, and I want to use the vertex formula to find it. X equals negative b over 2a is the vertex formula. How do I use it? I'm going to replace the b and the a with parentheses. Then, of course, I understand which one's my a, my b, and my c. We don't even use c on the formula. So I'm going to plug in the b value of 6. So 6 goes right here. The a value of negative 3 goes in here. And let's work this out. We're going to end up with x equals negative 6. Whoops. Negative 6 over negative 6. We should all know that a negative divided by a negative is a positive. So x equals positive 1. That means that the vertex x value is 1. And now we need the y value. How do we find the y value once we already know the x value? Plug it in. Thank you. So we're going to go back to the original. Y equals negative 3x squared plus 6x plus 5. Notice that I put parentheses instead of the x values. So we're going to be plugging in that answer of 1 because we found out that x equals 1 with the vertex formula. Now we're going to find y by plugging it in. Of course, we're going to use PEMDAS. Exponents first. 1 times itself. 1 squared is 1. So I really have negative 3 times 1. That will be negative 3. And then 6 times 1, that's just 6. So you have negative 3 plus 6 and then plus 5 at the very end. What is negative 3 plus 6? 3. What's 3 plus 5? 8. So our y value is 8, and there's the vertex. That is the most important point of the parabola. Let's graph it. So I'm going to go 1 on the x from the origin, 1 on the x, 8 on the y. Put a dot right here. That is our vertex. All right, right there. That's our vertex. Now, through any vertex, there's a vertical line that's called the what? What's axis of symmetry? So let's draw a green axis of symmetry going right through it. Now, if we were taking a multiple choice test just by knowing the vertex and knowing if it opens up or down. By the way, does this open up or down? Down. How do you know it opens down? The A is -3, so it's opening down, right? Okay, so just by knowing that, many times on a multiple choice test like the final, you'll be able to identify the correct graph. But this is not multiple choice, let's keep working. So I need more coordinates. So what do? I go to an XY table to get more coordinates. Now, what number do you think is the easiest to plug in? 0 is probably the easiest, right? Plug in 0. Now, if I plug in 0, we could actually do this in our heads. What is 0 squared?
0.
And what's -3 times 0? 0. What's 6 times 0? 0. What's 0 plus 0? 0. What's 0 plus 5?
0. Oh,
5. So when we plug in 0, we get an output of 5. Now that is a coordinate. Let me graph it. So I want to go from the origin, 0 on the x. I'm not going left to right, but I am going to go 5 on the y. 1, 2, 3, 4, 5, and let's put a dot right there. Okay, now, I could plug in another value. What would another value be good to plug in? Do you think, let me ask you this, guys. Do you think 1 would be a good option to plug in? No. You know why? I already plugged in 1. The vertex input was plugging in 1. It gave me the output 8. So if I plugged in 1, I'd get out an 8 again, right? Would it be, so that's not a good idea because we already did that. Would it be a good idea to plug in 2? No, it would not. Why not? Check this out. If I plug in 2 and I do all this work, all right, 2 squared is 4. 4 times -3 is -12. -12 plus 6 times 2 is 12. And then plus 5, that'd be 5 as an output. That was a lot of math to find out that the output's 5. But check this out, guys. If I actually go to the coordinate 2, 5 from the origin, 1, 2, 1, 2, 3, 4, 5, what would the easier thing to have done be is if you already know that this blue dot was a coordinate, all you have to do is reflect it to the other side of the axis of symmetry. Does that make sense? So this dot is 1 unit away, so I'm going to just go 1 unit away and put a dot right there. Does that make sense? So why would you plug in 2 and get out a 5 if you could just see the reflection of it 2, 5, right? So I guess the main point I'm trying to make here is up here on our steps. Step 3 is to plug in 2 numbers on the same side. Plug in 2 numbers on the same side of the axis of symmetry and then map their reflection onto the other side of the axis of symmetry. Make sense? So you don't want to plug in 0, which is on the left side, and then plug in 1 or 2, which is on the right side. You want to plug in 2 values that are on the same side. So maybe instead of 0, you want to plug in -1. -1. When you do plug in -1, let's actually do that work over here on the side. And we are plugging in a -1 right in there. -1 squared is +1. +1 times -3 plus 6 times -1 plus 5. Let's do the multiplication. -3 and then -6. So you have -3 plus -6 plus 5. -3 plus -6 is -9. -9 plus 5, -4. So when I plug in -1, I get out a -4. For my input -1, I get an output of -4. So let's actually graph that from the origin. -1, -1, 2, 3, 4, put a dot right here. And now what should I do next? After I already have another coordinate, what should I do with that other coordinate? With the axis of symmetry? Reflect it to the other side. It's as easy as this. Can we all count? Yes, we can. This is 1, 2 spaces away. So go 1, 2 spaces away and put a dot right here. And that's it. You have a very detailed parabola. You're done. Just connect the dots, put an arrow, connect the dots, put an arrow. As you can see, this parabola is a lot more narrow. It's not wide like this. It's definitely narrow. The A value is what determines if your parabola is wide or narrow, but we'll get to that later. Right now, let's just move on to the next example. This one took a long time because I wanted to explain every detail of it. Let me go a little bit faster on this next one. So right here, we're going to again start with the vertex, which is a coordinate, an x and a y value. Let's use the formula, x equals -b over 2a, and let's use parentheses. So what is the b value, guys? Looking at the standard form quadratic trinomial equation. Right now you should be thinking, wait a minute, it's not a trinomial. It's a binomial. It's ax squared plus bx plus c. Is there a bx? Is there a bx in there? There's definitely an ax squared. The a value is 1. There is no bx, right? So we know that the b value is what? What represents nothing? 0. So 0 for b. The a value is 1. And if you do this math, negative 0 divided by 2, that's still 0. So the x value is 0. So the vertex x value is 0. I need the y value. I'm simply going to plug it in. And when I plug it in, it'll be 0 squared minus 3. 0 squared is 0, and 0 minus 3 is negative 3. So the vertex is pretty easy. 0, negative 3, 0, negative 1, 2, 3. Let's put a dot right here. What's the next thing to do instantly after finding your vertex? What should you do after you plot your vertex? We already found it. We already put it on the graph. What's the next thing to do? The axis of symmetry. Perfect. If you look up at your notes right above this, step 2 is to do the axis of symmetry. So let me do an axis of symmetry going right through that vertex. Why is it important? Because it'll provide a reflection. It'll help us do it a lot faster. Let me move on to an XY table now. Okay? Now, would it be smart for me to plug in 0? No, why not? Because I already did. I plugged in 0, got out a negative 3. So let's pick 2 points that are on the same side of the axis of symmetry. So give me a value. Give me a value for x. Do you want to go negative 1, negative 2, or do you want to do 1 and 2? 1 and 2 that are both on the right side. You want them on the same side. So let's go 1 and 2. 1 and 2. So when I plug in, we could actually do this in our head. Plug in 1 right here. 1 squared is what? 1 squared. And what is 1 take away 3? A negative 2. Perfect. We have that coordinate. 1, negative 2. Let's go to the origin. Let's go to 1 and negative 2 and put a dot right here. And then let's go and plug in 2. 2 squared is what? 4. And then 4 take away 3? 1. So when we plug in 2, we get out a 1. And let's go to that coordinate. 2 on the x, 1 on the y. Let's put a dot right there. Now, I could plug in as many coordinates as I want. But knowing that the axis of symmetry gives me a reflection, I could just map them over to the other side and I'm done. Right? I could just draw the parabola. So let's do that. Let's take this first one, which is 1 unit away, and go 1 unit away this way. And let's put a dot right here. Now let's go to the other one, which is 2 units away at this level. So go 2 units away this way and put a dot right there. You see, it's easy. Easy. Put some arrows. You're done. Now, is there an easier way? Yes, there is. Crazy. Okay, check this out, guys. You want an easier way? Do we understand this, though? Because it's very important that we understand it. Okay? Now, here's a fact. The a value will tell you if your parabola is wide or narrow. Tells you if your parabola is wide or narrow. Okay, the a value tells you if your parabola is wide or narrow. Now we've already done the parent graph y equals x squared. The a value is 1. That's a regular parabola. Now, if I were to take that regular parabola of a being 1, if I were to make it 1/2, then your parabola would open up. If I made it 1/10, which is even smaller, it would even open up further. Does that make sense? Okay? Or let's go back to the a value of 1. It's a regular U-shaped curve. If I make the value 2, if I say y equals 2x squared, it'll make it stretched more this way. 3, 4, 5, 6, it'll make it more compressed, more stretched. Does that make sense? So the a value will tell you if it's wide or if it's narrow. The less value that the a value is, or I should say, the closer it is to getting to 0, the wider it is, the closer it is to becoming a flat line. So here's the a value of 1. Here's the a value of 1/2. Here's the a value of 1/5, 1/8, 1/10, 1/16, right? 1/16 is hardly anything, right? If you get your a value to be so low that it becomes 0, then you don't have a quadratic anymore, you have a straight line. So it gets wider and wider and wider until it becomes a straight line, right? Also, if your A value, here's your A value of 1. If your A value is negative 1, then it reflects it and it opens down. Okay?
So how does it become like a straight line?
How does it become a straight line? Remember, a straight line is only when you don't have an exponent of 2. So if you did have y equals ax squared, and you made it smaller and smaller, like y equals ax squared, like 1x squared, 1/2 x squared, 1/10 x squared. If you get so small that it becomes 0, then you're not going to have an x squared anymore. Because if you have y equals 0x squared, then it's just y equals 0, which would be a flat line crossing through the y value of 0.
Yeah, that makes sense.
Kill. Did that make sense?
No, I didn't get it.
I'm still recording.
You can just edit it.
I'm still recording. So I hope we understand that the A value of 1 will pretty much give you a regular U-shaped curve. The A value is 1 right here, right? Regular U-shaped curve, just like our parent graph on the beginning part of these notes. See, the parent graph had an A value of 1 also. It's a regular U-shaped curve. Now here's an amazing shortcut that I'm about to show you, okay? If you know that your A value is 1, you're going to be able to apply this shortcut. And the shortcut is this. If you go to the XY table of the parent graph, 1, 1, 2, 4, 3, 9, that is the pattern that we're going to be using. When your A value is 1, since we know that the A value changes the width or the narrowness of the parabola, if you know your A value is 1, you know that it produces a regular shaped curve, then anytime you have a parabola with the A value of 1, it's going to produce a regular shaped curve. And we're going to be able to use this pattern from the vertex. Guys, memorize this. 1, 1, 2, 4, 3, 9. Memorize that. 1, 1, 2, 4, 3, 9. Why is that? Because, check this out, guys. If you find your vertex, which we found the vertex, right? You use the vertex formula. You get your x value of 0, you plug it in, you find your y value, that's your vertex, you graph your vertex. You actually could graph the rest of the parabola without doing any math. What was the pattern? 1, 1, 2, 4, 3, 9. That pattern is always going to be the same if your A value is 1. Let's go to the vertex. Check this out, guys. Everybody focus right here. Check this out. From the vertex, let's say you found this vertex. If you go with the pattern from the vertex in any direction, 1 over, 1 up, you'll get to that next point. If you go 2 over, 1, 2, 3, 4 up, you get to that next point. Or if you go over 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, you could get to that point right there. So you're able to find all the coordinates and then map them over to the other side. What do I mean by map them over? Like this one's here, it's 1, 2, 3 away. So 1, 2, 3 away, put a dot right there. And you could extend the parabola as far as you want. So this pattern is amazing. Will it work on this one up here? No, because the A value is not 1. You could figure out a way, I'll show you later, to apply that pattern to that. But for the most part right now, we just want to understand that if your A value is 1, you could use the pattern 1, 1, 2, 4, 3, 9, and that'll help you graph it super quick. Now, I want to just show you how quick it could be. On the back side, we have our homework. This is what we're doing for homework. I'm going to go to number 1 because the A value is 1. I want to show you how amazing this shortcut is. Step 1, find the vertex. And we know the vertex is a coordinate, an x and a y value. Now, to find the x value, we're going to use the formula. X equals negative b over 2 times a. And of course, we're going to know how to use the formula. You have to use parentheses so you don't make mistakes. And we need to understand the a value is 1, the b value is negative 2, the c value is negative 1. So we plug in the b value of negative 2 right in there, and the a value of 1 right there, and I will get x equals positive 2 over positive 2. So what does x equal? X equals 1. So the vertex x value is 1. I need the y value. What do I do to find the y value? Simply plug it in. Use parentheses to plug in the 1. And we could do the math easily. 1 squared is 1. 2 times 1 is 2. So you have 1 minus 2, that's negative 1. And then negative 1 minus 1, that's negative 2. So your y value is negative 2. Let's go to that vertex of 1 on the x, negative 2 on the y. I put a dot right there. And of course, the second thing to do is to do a dotted line right through it, a vertical line that goes right through it. That's called the axis of symmetry. And now we need more coordinates. So one option is to actually go to an XY table. Probably should have done it in a different color. But the quick, fast way is to understand that the A value is 1, which means you could use a pattern. What's a pattern? 1, 1, 2, 4, 3, 9. Memorize it. 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. Now let me ask you this, guys. We already know that the vertex is the highest or the lowest point, right? So does the parabola open up or does it open down? Up, because the A value is 1. Okay, so it opens up. So I know it's going to be going up with this pattern. So let me do this. 1 over and 1 up. Right? The 1, 1, that means 1 over and 1 up. Put a dot right there. The next one, 2, 4. That means 2 over, 1, 2, 4 up. 1, 2, 3, 4. Put a dot right there. And if you wanted to go for the last one, 3 over 9 up. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to be off the graph. So you don't really even need to do it. But we need the coordinates on the other side of the axis of symmetry. Simply map them over. 1 unit away, 1 unit away. And put a dot right there. This other one is 2 units away. So let's go 2 units away and put a dot right there. And then the only thing left to do is to draw a parabola through those points. Put some arrows on it, and you're good. See, it only took a couple of minutes, guys. A couple of minutes to graph if you know the pattern. Now again, the pattern only works when the A value is 1. Number 2, it'll work right here. The only thing you have to remember is that it's opening down. So when you go 1 over, go 1 down. When you go 2 over, go 4 down. When you go 3 over, go 9 down. Because the A value is negative, it's opening down. Right here, you cannot use the pattern. Maybe on a different day, I'll show you how to force the pattern where your A value is not 1. Right here, you can't use the pattern, and so on and so on. So for tonight, I want you guys to practice graphing. You might have to use a table, but if your A value is 1, you could use the quick pattern 1, 1, 2, 4, 3, 9 from the vertex.